Hey everybody, welcome back to yet another fun and exciting pre-calculus class. Today we're going to be in your book on page number 6, reviewing of graphing. Wow, it's like all of these things we're reviewing in one class, what it took us weeks to learn in other books. But that's pre-calculus. We got to just quickly go through this so that we can get into the trigonometry and pre-calculus section of the book. So hopefully you're keeping up. I know the last two lessons, there was a lot there to remember, but I think with a little bit of practice on those exercises, hopefully you remember what we were doing. This lesson is the same. We're just going to do another review. This time we're going to talk about graphing. Let's start with the line graph. All right, so this is on page 6 there at the bottom. You will see here it's where it says review of graphing. We're going to start with the number line. The number line is the line extending indefinitely in both positive and negative directions. This is a number line. I don't think I have to go over the number line. We pretty much have been using the number line for years and years, and you should have a good concept of it. Notice this spot right here in the middle. 0 is called origin. That's very important. I'm going to use the word origin a lot this year. So you should always know that that's the 0 line, or if we're in the Cartesian plane, which we're going to talk about in just a second, then it's the 0 point on the x and the y. So we'll talk about that in a little bit, but the concept that I want you to understand right now is origin. It's where we're starting. It's the 0 line. All right, so if we want to find the distance between 2 points, we're going to use a very simple formula, and we can go over here and take a look at that formula. It is d for distance equals number 2 minus number 1. All right, and so what we're going to do is just give different values. I think there's some examples in your book there. You can look on page number 7, and you can see a couple different examples there. So the first example says if we start at origin, so our, let's call it number 1, or I could call it point 1, but we'll say number 1 is origin, and that's 0, okay? And then it says find the distance from origin to point -4. So number 2 is -4. And what we want to do is we want to find what is the distance on the number line. So let's go up here to this formula. Now, a couple things to notice real quick about the formula before we start plugging into it is that it's number 2 minus number 1. Now, that means that we're going to plug in with the signs and everything. So let's just go ahead and plug into it and see what that looks like. So don't forget these. I want to talk about these in just a second, but let's put those right there. And then we need number 2. So what's number 2? It's -4. So we're going to put -4 minus what's number 1. Number 1 was 0. So there is our just plugging it into it. Now, what are these little sticks out here, right here? What are these walls that we put up on the outside? Well, that means absolute value. What does absolute value mean? Well, absolute value really in its base definition just means the distance from 0. So in other words, we need this in finding the distance because that's what we're trying to do. We're trying to find the distance from 0, or the distance between the two numbers. Another way to think about absolute value is that it's just the quantity, the sheer quantity of movements on the number line. So if you moved 7 places, it doesn't matter if you move 7 places to the left or 7 places to the right, you just moved 7 places. So absolute value is the number of movements you're making on the number line, positive or negative, doesn't matter. The way that we do that in math is we just take the positive value out of the, so if we have a negative value inside the absolute value, when it comes out, when we read the answer, it would just be the positive answer. So we're going to get that right here. This is going to be one of those types of questions. So if I have -4 and I subtract 0, that means I still have -4. So the answer to this would be absolute value of -4. Well, what is the absolute value of -4? Well, the absolute value of -4 is 4. Okay, and technically it's not positive 4. That's an interesting question right there. It's just 4. It's 4 units. Okay, and that's what absolute value means right there, is it's 4 units. So the distance of this 0 to -4 is 4 units. All right, let's do another one. Example number 2, they give you a couple different numbers. They say the distance between 5 and negative 3. So number 1 is 5 and number 2 is negative 3. Now I want to show you this one because it kind of messes with this negative sign right here. So just, copy it down. So we're just going to insert the number. So the 5 goes, the 5 actually goes here. And let me show you something else that's cool. Okay, you're going to like this. So I just said the 5 goes here. Well, the 5 can go there. So let's do it with them switched. Let's do it with this as the number 2. Let's kind of swap them around. And so if we put 5 minus 3, remember absolute value, what does minus mean? Well, that's going to turn those into positives. And so we're going to get what? 8. Absolute value of 8, which is 8. Now check this out. What happens if I do it the other way? So what happens if I put this negative 3 in there? Does it stay the same? Well, let's see. So I put negative 3 in there at the beginning. Negative 3 and then minus 5. Okay? Well, if we do the rules of math, and here's what the rules of math would state. If we're subtracting, we would change the sign of the second. So in other words, we change the sign of this 5 and we add. Okay? How do we add negative numbers? This would give us a negative 8, its absolute value, so it would still come out to 8. It doesn't matter the order of your numbers right here. You're going to get the same answer. The reason why you're going to get the same answer is because of those absolute value sticks that are out there. Okay? Technically, one answer would give you the negative value of it, and one answer would give you the positive value of it, but it doesn't matter because we're inside the absolute value, and that value is going to end up coming out anyways. So it really doesn't matter which way you go there, but just kind of use the formula that they give you, which is the minus. Okay? All right, the next section in your book there is the section on the Cartesian plane. Now, let me switch over there to the book real quick. So the Cartesian plane was really developed by a French mathematician, scientist, René Descartes. And one thing that you will not find in most textbooks, you just won't, is you won't find things like this right here. You won't find the fact that René Descartes was, if not a Christian, a believer in God. Look at what he says. It is really only God alone who has perfect wisdom. That is to say, who has complete knowledge of the truth of all things. In other words, through his, and René Descartes, man, he came up with so many different things. He was cutting edge on different things in science, different things in math, different things even in the study of God. And one thing that he got out of that, one thing that he understood through all of it, was that he can never, as smart as he was, he could never attain to God's wisdom. He could never attain to God's knowledge. And it's really cool to see somebody like that, so smart, so intelligent, so wise, but ultimately surrendering to the fact that God is infinitely wiser than him. God knows all things. And so again, you're not going to find that in most textbooks, but René Descartes, he came up with the Cartesian plane. Now, they named it after him later, but he developed the idea of the Cartesian plane. All right, what are some key things on the Cartesian plane that I want you to know? Let's jump back over here to this screen and let's look at some key things. Really the big thing is this, and I can switch this over to graph paper, so maybe this looks a little bit better for you, or something that you're a little bit more used to. All right, so the Cartesian plane has an X and a Y. The x-axis is the line that goes east and west, okay? The line that goes across. This is the x-axis. The one that goes north and south, or up and down, is called the y-axis. Very important that you understand which one's the x and which one's the y. If you don't get that, then we have a problem. So you need to make sure that you understand the x and the y. Now, each one of these little blocks, I'll blow this up just a little bit, but each one of these little blocks right here, okay? And so there's all kinds of these little blocks, right? But each one of these little blocks right here stands for something, and each line stands for something. And you can actually make it stand for whatever you want. So you could say, okay, so that's 10 and that's 20. Well, that's fine. And that's 30. Well, that's fine. You could also say that it's 1 each. You could say, okay, this one's 1, this one's 2, this one's 3. You could make them be whatever value that you want to. Typically, we make them 1, 2, 3. But think about if you're having to graph, like let's say that your x coordinate, you have to go 20 over on your x. Well, if you're counting by ones, you got to go a long ways. But let's say that you're counting by fives. Let's say that this line is 5, 10, 15, and then there's our 20 right there. Okay, so we would just go right there because we counted by 20s. So you can do some of that here in Precalculus. You're going to get some things, usually in Algebra 2 and things like that, you only counted by ones because you didn't need to count by anything different. But here in Precalculus, maybe you need to call each one of those lines something different. You could count by 2, so 2, 4, 6, 8. So 2, 4, 6, 8, counting by 2s. Count by 3s, count by 5s, whatever you want to count by. But you just need to label what you're counting by, what each one of those things. But here's what each one of those things represents. Each one of these things represents a unit of measurement. 1 inch, 1 yard, 1 unit, whatever the unit is. Sometimes in pre-calc, we don't even talk about what the unit is. We just say that it's 1 unit. Okay? So, couple other things, and it's in your book there on page number 7, and I've got it written down right here. It's talking about these words, the abscissa and the ordinate. The abscissa and the ordinate. Now, it's important to kind of keep an understanding these because it seems a little backwards. So if you'll read this, it says the abscissa is the distance from the y-axis, and that is true. However, notice that the abscissa is the x value. So you're like, wait a second, you just said the y value. No, I didn't. I said it's the distance from the y, which gives you your x value. So let's go back up here and look. So here's our x value, right? Let's say that the x value is 5. So we have to go 5, and so here's the y. So we're going 1, 2, 3, 4, 5. Our x value is right there. We went 1, 2, 3, 4, 5 units away from the y. Notice we went away from the y. Okay, so go back to this definition. The abscissa is the distance from the y, and it's your x value. All right, the next one is called the ordinate. And what is the ordinate? The ordinate is the distance from the y-axis, or your ordinate is your y value. Okay, so you have two values, an x value and a y value. Notice down here, I wrote, the pair of values is written together and is called coordinate points, also called ordered pairs. Sometimes you'll hear me call it coordinate points. Sometimes you'll hear me call it ordered pairs. So here's what that looks like. Here's the way we write that. X, comma, y. And we put that in parentheses. When you see that in algebra, when you see that in any type of math, you need to think coordinate points. All right, so in other words, we have the x. Let's say that x equals 5 and y equals -3. The way that we would write that is 5, comma, -3. You always write the x first, then the y. So it's always the x, comma, y. That's the way that we write coordinate points or ordered pairs, whichever way you want to say that. Okay? And to be honest, that's about all that I have for you in this lesson. And then the lesson continues to go on and give some different exercises. Go through those exercises. One thing about doing the exercises is this. If you ever want to be the best at whatever it is. If you want to be the best at baseball, well, you better practice baseball. I lived in the Dominican Republic for 10 years, and I learned all kinds of different baseball players, and I learned a lot about them, and I met them, and I talked to them. And one of the things that's the same for every baseball player, if you're going to work in the major leagues, if you're going to play in the major leagues, and it's work for them really, but if you're going to play in the major leagues, how do you get there? Working, practicing. You don't just throw a baseball one time and say, oh, I want to be a pitcher. No, you practice and practice and practice and practice, and that allows you to be good enough to be a pitcher. How are we going to get good at pre-calculus? We're going to work on it. We're going to practice, we're going to practice, we're going to practice, and we're going to get better at it and better at it and better at it, more proficient at it every time we practice. So keep doing those examples, keep asking questions, keep working hard, keep doing your best, and I think throughout this year you will see fruit of your labor. So keep doing your best, okay? That's all I got for you. You have a good one. Bye-bye.